By July 2026, global tech layoffs have officially crossed the 120,000 mark, and major enterprise firms are completely freezing entry-level onboarding. If you are a second-year computer science or BCA student, relying on the fact that you know Python syntax to clear your upcoming campus placements, I need to give you a brutal reality check. Major enterprise firms are not freezing these student hires because of a sudden budget deficit. The capital is there. They are freezing hires because they are facing an automation reality. Autonomous coding fleets are now handling the entirety of their boilerplate tasks. When your resume says proficient in Python, Django, and basic script writing, you are competing directly with AI tools. Those agents execute your exact workflow in seconds for fractions of a cent. Writing a clean, functional Python script is no longer a marketable human skill. Today, we are looking past the syntax. We are breaking down the hard data of why just Python gets your resume instantly filtered out by recruiters, and identifying the structural platform skills enterprise teams are desperately searching for. We will cover exactly how to entirely rebuild your portfolio to survive this market shift. In late 2026, candidates who rely solely on abstracted syntax knowledge are effectively presenting themselves as obsolete commodities. To understand why resumes are being rejected, we have to look at the computational economics of modern engineering. In the past, securing a junior role meant companies needed your hands to manually type out data parsing loops and construct basic API endpoints. In July 2026, that entire tier of manual labor has been completely absorbed by the token economy. This comparative diagram shows exactly how enterprise command line agents operate. They spin up perfectly structured Python backends from plain English instantly. This means standard student projects like weather apps or basic scrapers carry zero weight. When a recruiter opens a portfolio filled with these basic implementations, they see a candidate whose entire body of work can be generated by an AI in 3 seconds. Knowing libraries like NumPy, Pandas, or Basic Flask has transitioned from a strict human requirement to a freely available AI-generated commodity. The market has successfully detached human value from the act of code generation. The new pillars of human value are code orchestration, system optimization, and security governance. Presenting a syntax-heavy portfolio today proves to employers that you completely fail to understand the current economic mechanics of software engineering. This brings us to the most significant flaw I see during technical reviews of student resumes: the tendency to fake foundational theory. Python makes it incredibly easy to import massive machine learning frameworks with a single line of code. Students look at a running print statement and suddenly claim they are AI engineers. If you walk into an interview and rely on those abstracted imports without understanding how they work, an experienced tech lead will weed you out in the first 2 minutes. The most common conflation students make is failing to distinguish between deep learning and shallow neural networks. This visual model contrasts the two architectures. They possess entirely different mathematical footprints. A standard neural network executing a shallow classification task is mathematically simple, running efficiently on a local device for minimal compute. In contrast, a massive deep learning transformer or long horizon agentic pipeline demands heavy distributed cloud resources to function. Writing code that calls a massive deep learning API when a lightweight local neural network could easily solve the problem demonstrates gross incompetence.
The compute penalty incurred by this mistake highlights a vast difference in physical hardware costs for the company. An enterprise views this architectural failure as a recurring financial penalty, where every unnecessary API call drains the project's actual runway. True engineers must know the underlying data structures and execution mathematics, not simply how to memorize Python keywords. Understanding exactly how code maps to physical hardware is the definitive dividing line between junior scripters and hireable engineers. Audit your own portfolios right now. Look for instances where you are executing massive compute waste to solve simple data problems. In 2026, companies cannot and will not subsidize the server costs of mathematically ignorant developers. Failing to map your mathematical models to their physical hardware costs immediately marks you as an inefficient liability. So, how do we adjust our project-based learning strategy this month at APJ Staya University to ensure your resume actually stands out? You must transition your professional identity from a Python coder to a platform and systems engineer. This architectural diagram illustrates the first rule of this pivot. Stop building isolated, standalone scripts. Your upcoming projects must incorporate platform rigor through robust data infrastructure. You need to architect scalable vector databases and configure secure cloud microservices that interact flawlessly. Managing distributed system parameters across these instances is now an entry-level expectation. The second mandatory upgrade requires focusing strictly on automation and quality governance. Simply proving that the code works on your local machine is unacceptable. The active process of deployment must be showcased. Design automated CI/CD pipelines directly within your GitHub repositories. Implement static code analysis gates and unit testing runners at every deployment stage. These automated software gates must actively audit the code for vulnerabilities and performance bottlenecks without any human intervention. Presenting this level of infrastructure proves to recruiters that you know how to police, stabilize, and scale software in a live production environment. Consider Python syntax the entry fee for the 2026 market. The real engineering happens at the platform level. If you want a complete step-by-step breakdown on how to upgrade a standard Python project into a robust Dockerized platform architecture with automated testing gates, let me know in the comments. The software industry in late 2026 belongs exclusively to system architects and platform governors who move past basic syntax to build systems that matter.